All right, welcome back to the deep dive. Today, we're diving into the economics of industrial fermentation.
Economics.
Yeah, really drilling down into how engineering choices, when you're designing these processes, how they directly impact whether you can turn a profit or whether you go bust.
Yeah,
So
absolutely.
we've got a whole stack of research here looking at exactly how those technical decisions you make early on end up impacting your pounds, shillings, and pence, euros, dollars, whatever you're working with.
Right, exactly. The bottom line.
That's the mission here. We want to pinpoint those crucial elements, the things that really make or break you when you're designing a fermentation process.
I think this is really critical because we're going beyond the biology here. A lot of times people get really excited about the organisms and all that, but it really comes down
That's the
to,
nuts and bolts.
yeah, the nuts and bolts and how these systems are actually built, operated, and ultimately whether they can make money, right?
Make money. Yeah, exactly. Okay,
Yeah.
so let's start at the beginning. Capital costs.
Yeah.
This is that mountain of investment you're going to make before you even get started.
Right up front, yeah.
One of the big things that keeps coming up in the research is bioreactor design and size. Stirred tank, airlift, even membrane bioreactors. What are we looking at here for economic trade-offs?
Well, stirred tank, that's kind of the workhorse, right? It's what a lot of people are familiar with.
Right.
But it can be energy intensive. An airlift or a bubble column, those can actually, for certain applications, really slash your energy bills.
Really?
Yeah, for mixing. You're
Yeah.
talking sometimes like 30% lower energy for mixing just by changing the design.
Wow. Interesting.
Then you have to think about scale too. Do you go with, 1,000-liter bioreactor? Or do you scale up to 10,000 liters? Because often moving to that larger scale can bring down your per unit production costs.
Because of economies of scale, right?
Exactly. You can buy your media in bulk. You're not cleaning as often. You might see savings of, say, 20% just by scaling up. But of course, with that bigger scale comes bigger risk too, right? That's a much bigger upfront investment.
If it doesn't work, it's a lot more money down the drain.
Exactly.
And then it's not just what type of bioreactor, but what it's made of, right? Stainless steel, that's the classic.
Yeah.
Versus these single-use systems, which are becoming more popular.
Right. That's a big decision right there. Material choice.
Huge cost implications.
Absolutely. Stainless steel, you're talking big upfront costs. You got to have SIP, CIP, those systems for sterilizing and cleaning in place. Those are essential for keeping things pure, but they add to the cost.
Yeah, exactly.
Single use, it lowers that initial barrier to entry. But then you're constantly buying new stuff, consumables, and that adds up over time.
So it's a trade-off, like short-term versus long-term.
Exactly. Yeah. And then, of course, you have automation. That can be a big chunk of change up front, but in the long run, it can really save on labor, improve consistency, and you might even see it pay for itself in a few years.
All right, let's move downstream now. Downstream processing, or DSP, also a major capital expenditure, right? It seems like the less steps you have, the cheaper it's going to be.
Absolutely. Every step you add, you're adding equipment, complexity, and cost.
Right.
So choosing something like precipitation over chromatography, if you can,
Yeah.
that can make a huge difference in your equipment costs.
Because chromatography is a lot more involved.
Yeah, it is. But of course, chromatography gives you higher purity, so it's a trade-off there. You have to decide what level of purity you actually need.
What's good enough, yeah.
And this is really important. Whatever equipment you choose for DSP, it's got to be sized correctly to handle the output from your bioreactor.
Oh, yeah. You don't want a bottleneck there.
Exactly.
Yeah.
If you're producing tons of stuff in your bioreactor, but your DSP can't keep up, that's a problem. Okay, now something you might not think about right away as a cost driver, but it is plant layout.
Yeah. Interesting. Explain that one.
It sounds kind of boring, but a smart layout, it minimizes your construction costs, and it makes everything flow better, materials, personnel, which then impacts your operating costs later down the line.
So it's thinking ahead.
Yeah, exactly. Plus, if you're working in, say, pharmaceuticals, you've got to meet GMP, good manufacturing practice. And that adds a whole other layer of cost because of all the documentation, environmental controls, and everything that goes with it. Okay, so that was the upfront investment, the big capital costs. Now let's talk about the day-to-day expenses, the operating costs. One of the biggest ones, I think it's pretty obvious, is maximizing your raw material utilization.
And making the most of what you put in.
Absolutely. You want to squeeze every bit of product out of those raw materials.
Get that yield up.
Yep. And a lot of the research we've been looking at points to this. Cheaper feedstocks, that's a game changer.
Like what? Give me an example.
Well, instead of using, refined sugars, you could use molasses. Or even something like lignocellulose that's from agricultural waste.
Wow. Using waste products
Exactly. Turning waste into profit.
That's pretty amazing.
It is, yeah. And then if you can recycle your media, you're hitting both raw material costs and waste disposal costs.
Double whammy.
Right. All right, now another big one, energy efficiency. Fermentation can be a real energy hog.
Yeah, all that heating, cooling, mixing.
Exactly. So using a low energy bioreactor design, something like an airlift or a bubble column, that's a good place to start.
Yeah.
And then optimizing your aeration, your mixing, even something as simple as recovering the heat that's generated during fermentation, that can save you a lot of money.
He's smart.
And, water is becoming more and more scarce, so minimizing your water usage and your wastewater treatment costs, that's becoming increasingly important too.
Makes sense.
All right, so we talked about how DSP impacts your initial investment, but it also plays a big role in your day-to-day costs.
Okay. How so?
Well, if you can get a high yield in your bioreactor, that directly translates to lower DSP costs. The less you have to purify, the better. Fewer steps, simpler process, lower cost.
Makes sense.
And then there's continuous processing. Instead of doing things in batches, you have this constant flow. That can really boost your throughput and cut your operating costs compared to those traditional batch methods.
Interesting.
Yeah, a lot of potential there. Now, we talked about automation before in terms of capital cost, but it also has a huge impact on your operating costs. It can really cut down on labor and improve consistency. And finally, let's talk about waste. You're always going to generate some waste in fermentation.
Yeah, it's a fact of life.
It is. So the less waste you generate, the better. But here's the really interesting part, byproduct utilization. Can you take that waste and turn it into something valuable?
Like what?
Well, one example is biogas. You can take that waste and generate biogas, which you can use for energy.
Wow. So you're offsetting your disposal costs and generating energy at the same time.
Yeah, exactly. You could even potentially sell that biogas and generate some revenue.
So basically, it sounds like the economic success of fermentation really comes down to this holistic approach to design, thinking about all these interconnected factors from the get-go.
Absolutely. And it's not like you just design it once and you're done. It's an iterative process.
You're constantly tweaking, right?
Yeah, you're always tweaking, you're always optimizing. And tools like simulation and economic modeling, those are crucial for helping you find that sweet spot, that balance between technical performance and financial viability. Because every decision you make has ripple effects.
It all comes back around.
It does. Okay, so the key takeaway here is pretty clear. Smart process design and fermentation, it's not just about good engineering, it's the foundation of economic success.
It's about being profitable.
Exactly. And it impacts everything from your initial investment to how efficiently you operate in the long term.
Yeah.
Every choice you make, the type of bioreactor, how you handle your waste, it all has an economic weight.
All right, so final thought here for our listeners. We've talked about all these interconnected design elements. What single factor do you think has the most potential to really revolutionize the economics of industrial fermentation in the coming years?
That's a good question, I think.
Something to think about. We'll be back next week with another deep dive.
See you then.
Thanks for listening.